All right, so we're going to start off today going over geometry as it was traditionally done by Euclid. Euclid was a guy who lived in the Egyptian time of Necta-Khanivo. So this is back about 400 BC. They had just beaten the Persian army. They were building temples, and they had just started mummifying animals, specifically baboons. Now, one of the things that they needed to do was they needed to make a bunch of temples with, say, a bunch of blocks that all needed to be the same size. So they needed to reproduce angles, they needed to reproduce congruent segments, and they didn't want to give their workers with jobs nice tools. So what they would do is they would construct congruent line segments, congruent angles, and angle bisectors using a stick, like the one that I collected, and a string. So we're going to talk a little bit about how they measured things and do what they would do. Let's start with making two congruent line segments. So in order to make two congruent line segments, we need a random line segment to start off with. So a line segment starts at a point. Could you go ahead and touch that point with that rope? And then it ends at a point. So here's our line segment originally, and we're going to make a line segment that's completely congruent to that without actually measuring it. So we know we start at a point. Go ahead and with a different part of the rope, please. Thank you. We're going to just go off almost like we were forming an array here. We started at a point, we kept going, and we need to figure out where this line segment needs to end so that it's congruent to this line segment. So what we're going to do is we're going to tie a rope in the end of our, tie a knot in the end of our string, put our stick through, and measure. We're going to use this measurement technique on the rest of these constructions, so pay attention to that. We're going to just make a little arc from one point to the other point. We can do the same thing here, make your little arc from one point to where the other point needs to be. Now this segment, which we will call AB, is congruent to our new segment, which we can call CD. And now we have two congruent line segments, so we could make two bricks of equal length. All right, let's keep going. Now, let's say you didn't just want a line segment of the exact same length, you wanted a line segment of exactly half that length. So we need to make another line segment. Start at a point. Go ahead and touch that point. And we want to get exactly half of this point. So what we're going to do is we're again going to stick our stick through our knot, and we're going to make two arcs this time. These arcs are going to be of equal radius. So radius is the distance from the center of the arc to the arc itself. Okay. We're going to do the same thing over on this side. Now you'll notice that these arcs don't intersect the circle at the same spot. But if we connect these two arcs where they intersect each other, we're going to go ahead and line up the rope with the points of intersection of our circles with each other and connect those dots. Now what this gives us here is an intersection that cuts this line segment in half. The other thing this gives us is this isn't just an intersection, but it is a perpendicular bisector. These two lines touch each other at right angles. So now we can copy a line, we can cut a line in half, and when we cut a line in half, we can make a right angle. Now, the other thing we need to know is, so we know how to make a right angle, but what if we wanted some other kind of angle? So an angle starts at a vertex, and then goes off in some random direction. Let's say we wanted to replicate this exact angle. Well, we would need to start off with a ray. And now what I'm going to do is I'm going to measure this angle, again, using the radius of an arc. So I'll measure this angle, and I'll put the same arc off of this random point we already made. Now, in order to make sure the angles are congruent, we'll measure the points of intersection of the arc with the two pieces of the angle, right there, and right there. And then we're just going to connect our original point to the intersection of the arc. Here we go. So that's how we would replicate an angle. Now, just like how we wanted to replicate a line segment, and then we wanted to cut the line segment in half, we also want to be able to do the same thing with angles. We want to be able to cut angles in half, or make an angle bisector. Okay, just like with our previous angle, we need to start with a point. Take some kind of straight edge off that point. Get a little bit bigger. All right, that looks good. Now for this, what we're going to do is we're going to make 3 circles of the same radius. One circle centered at the origin of our angle, and the other 2 circles centered at where that circle of the origin intersects the angles. All right, so let me show you what I mean. So here's our first circle. Now you see these 2 points where our circle intersects our angle? We're going to make circles of the same size around those points. Well, you'll notice that they have a point of intersection right here in between the angle. But if I connect the origin to that point of intersection, I'll cut this angle perfectly in half, and we have our angle bisector. And that's how we used to do constructions.